Looks like we are live. Hey everyone, welcome to another session of the Contributor Roadmap series. Contributor Roadmap, if you don't know, is a step-by-step approach towards open source contributions with interactive sessions and mentorship. If you're someone looking to gain exposure as a first-time contributor to a particular project or open source in general, this is definitely an opportunity you would not want to miss on. Do check out the roadmaps using the link that will be dropped in the chat. In this session, Rabi, who's a software engineer at Zoko, will be introducing the explorers to the Go language, and telling us what's the hype about. He'll also be demonstrating how you could go about using the Go client for Typesense. Thank you so much for joining us today, Rabi. Over to you.
Hi guys, so I hope everyone are having a very good evening. Let me just share my screen. So I'll just start with the slide. Okay, so basically today I am here for introducing you guys to Golang, and along with that we'll also have a very brief introduction to Typesense and its Go client. So let's begin. So first of all, who am I? Well, I am Rabi Roshan, and I am a BTech Computer Science and Engineering graduate from CUSAT. So there are two things I love to do the most, that is coding and football. So today we are here to talk about the first part, that is coding. Football maybe we will have to do it some other time. So in coding, basically I like doing both front end and back end, but however, like I'm more experienced in front end and mobile development using React JS and Flutter. So 2 years back, I was fortunate to join Zoko. So essentially, what Zoko does is we leverage WhatsApp Business API to provide to build our product, which our clients use for marketing, sales, and customer service. And we are kind of becoming a brand in this section. We of course we have other competitions, but we are kind of like becoming a brand. It's going in a good way. So even though I joined as a React.js developer, I have been doing backend using Golang for the past 1 year at Zoko. So that's enough about me. We'll start with what is Golang. So Go is also like basically the language's name is Go. However, it's more used as Golang. So it is an open source compiled and statically typed programming language which is designed by Google. So I am emphasizing on compiled and statically typed because like basically that is what makes it different. So it is like C, C++ and all. It gets compiled to binary, and it has a statically typed. So basically, if you are familiar with JavaScript and all, there is no types. Like there is no like nothing like you have to when you declare a variable, you don't need to know its type, right? Let's say a variable is equal to 1, which is an integer. It can be also assigned to a string, etc. So basically, it is built to be simple, high performing, readable, concurrent, and efficient. Again, I'm emphasizing on concurrent because unlike other programming languages, concurrency is built into Golang. So by concurrency, what I mean is doing multiple things at the same time. That means if you are running two different functions, let's say function A and function B, usually it will be run one after the another. Because our machines are so fast, we might not notice that, but it's always run one after the other. But concurrency means both should be run at the same time. In other languages, like for example, let's say Java or Python, we have to do it it's really difficult to do it. It's not straightforward thing. We might have to import another packages or libraries to do that. For example, in Python, we use a thread library. I think I don't know if I'm correct. So something like that. So in Golang, it is built in. It's basically Go routine, which we'll talk about later. Uh, let's get moving. So why is Golang like? There is a lot of other languages, and why a new language? Like why make it a big deal? So basically, these are the main things, and simplicity, readability, efficiency, and concurrency. However, again, emphasizing on concurrency and simplicity. So why simplicity? Why did I write it as a curse and a gift? So I, as I said, I am more experienced with JavaScript and Flutter like languages, in which there are like a lot of shortcuts and tricks and tips there. Like to do a particular thing, there are multiple ways, and some ways are easier than the other. Like let's say there is a way of doing a function A. We can do it like in 5 lines or 2 lines in JavaScript and Flutter, etc. But in Golang, there is only one way. Basically, you don't need to know some ninja kind of skills. For example, let me just explain you that. Let's say uh, you might be knowing this ternary operator in other languages. For example, in JavaScript, if you want to assign A equal to, if B exists, you want C, otherwise you want D. Something like this. This cannot be done in Golang. In Golang, you have to go with the good old if-else conditions. If B, like A equal to C, otherwise you get my point, I guess. So this is where it comes. So that is why I said it is a curse for me when I'm doing something simple. In Golang, it is a very big deal. Something you can do in JavaScript with 5 lines, you might have to do in Golang with like 10 or 15 lines. At the same time, it is a gift because everyone, even a newcomer, can come and read the code and understand, because there is nothing magical. Everything is just simple. Whatever you see on the screen, that is how it works. Okay, cool. Let's get moving. So now, where is Golang used? Uh, so Golang is now being widely used by a very like a lot of awesome teams. Like a very popular examples will be Meta being Facebook, Netflix, Twitter, Uber, Twitch, etc., etc. Apart from this, a lot of open source guys like Kubernetes, Docker, Heroku, which are currently the main guys out there, right? They are also using Go as their main thing. Why? Because Go is oriented for cloud-based programming language. So you guys can ask why Go? Like there are other programming languages which has been doing this for a lot of time, right? But if you really think about it, cloud-based programming is something that became a lot popular recently, right? So all the older languages, they were not designed to do this. So most of the languages were designed to run on a single machine, maybe on a single processor, right? They cannot leverage a lot of multiple processors sitting on different computers at different places. But Go was designed just for this thing. It can leverage like multiple, like different CPU sitting at different places very easily. Just like when I talked about concurrency, that was built in, right? This thing is built into Golang. So it is very easy to do these type of cloud-based programming. That's why these guys are doing this. And like some of the guys even call this as the new Java, because a lot of open source programming languages are now written in Go. Like when you think about this, all the projects, right? All the projects like Apache Kafka, Apache Spark, etc. All those were written in Java. And recently the trend is everyone are using Go. So there is a very good future in Go if you guys are going along with this. Uh, okay, so that is enough about Golang. Like as an introduction, we'll get into the coding part later. So before that, most of you guys might be here because, like for Typesense. So I'll just give you a very brief introduction about that. So essentially, what Typesense is, like before getting into Typesense, let us see a situation, like scenario. How would you guys implement a search in your application? Usually, all the data resides in your primary database, which can be MongoDB, Postgres, etc., something like that. So the straightforward thing is write an API, like do some logic for searching. Basically, the API accepts the search query. You guys do very complex logical queries in Postgres or MongoDB to get the result, right? This has two main disadvantages. So mainly being the like how do you guys search? Like let me just show you an example. So in Google, right? We go to Google. So every keystroke is searching something, right? So this is taking a very hit. This will take a very big hit on your primary database. If you're using this, like if you're using a direct API to connect to your primary database for like for searching, it will take a very big hit on your primary database, which will make your app very slow. That is one of the reason. The second reason being the complex algorithms and queries, right? Like you can never get into something like this Google search engine is really good, right? You can never make this in a single night. So what essentially uh, Typesense is, they have written, like they have done all the hard work for you. You guys basically have to supply the data. So basically, Typesense is a database which specializes in searching. So you will have your primary database, and all the data that you need to be searchable, you will have to sync it with Typesense database. So all the complex queries are taken care by them. You will only have to give some configurations and just call their APIs, basically the search API. So it is that straightforward. Other alternatives for Typesense is Algolia, Elasticsearch, which most of you guys might have heard. We are using this in our company. So essentially, these are same things. These are competitions, but however, Typesense has a like more new approach to this, I guess. They are open source. So for a full comparison, you guys can check this link out. I went through it and it seemed like there is enough and more data to make your decision to choose a search engine. Now there is a Golang client for Typesense, which is built by them, the community. So why is there a need for Typesense Go client? So they have written all the complex Golang code as well. We only need to call the high level functions to access the database, Typesense database, to put index the data into the database, etc. If they haven't written this Go client, we will have to do all the HTTP calls to the database and etc. All the connections and stuff. So all the hard work has already been done there. We only need to go and import this and use it. So that is the brief introduction to Typesense. Now we are getting into the main part, that is basics of Go. This might be a little bit boring because there are a lot of things to cover. So let me just go. We'll start with Hello World. So before going with this, I'll just show you a website which we are going to use it right now. Go by example. So this website covers all the things. And today we don't have enough time to go through all of this. I'm just cherry picking some of these topics and I'll just explain them. So if you guys have been doing other programming language, it will be very like fairly straightforward thing. So we'll start with Hello World. You know, the main thing, everything start with this Hello World. So wait a second, is there any questions or something? Nothing, right? Okay. Yeah, there is no response, so it's very weird. I'm talking to myself. Am I? All right. Okay. So this is a very simple piece of code. I'll just show you running this file. Okay. So go run. Is this visible? This terminal? Okay. Go run, and we'll have to give the file name. It can be main.go, or if there is a multiple go line, if you want to run everything, it's just a dot. This is a shortcut. If you run this, see, basically it prints hello world. So before going further, I'll just explain the folder structure, like the files here. So if you guys are familiar with C or C++, we know there is a main file and a main function, right? Similarly, in Golang, every Go program starts its execution from the main function. So by default, the compiler, it starts from this function. So where should this function reside in? It should reside in a file with a package name. So in Golang, basically every piece of code belongs to some kind of packages or modules, you could say. So this complete thing is a module. Okay, within module there sits packages. You can make other packages as well. So there is a thing like, for example, if you create a folder, let's say package one. Now every file within this package one should have that. Let's say like testing.go. This thing should have its package name. Package should be basically, usually it is the folder name itself. Okay. Now we can write some piece of code here. If there is a file two, let's say type testing copy of testing second file, test two. So here also package one. So these two files now belongs to this single package. So if you write a variable here, let's say a equal to 1. Okay. you can actually use it here. B equal to A plus 1. Wait a second. Okay, so essentially within the packages, right, you can mix and match things. So basically, why are we splitting it into two files is just for our readability. Finally, from the angle of Golang, every package is a single, very big single file itself. It doesn't matter to it. So why are we splitting it into two different files? Is when number of lines of code in a single file gets very huge, right? It will be hard for us being humans to read it. So we will essentially need to split it into different files. So when you are splitting it into different files, you just have to maintain this thing. Package name should be same. So everything within the same package will be accessible by, here, like, eh, eh, I mean, like this file variables can be accessed with this file like that. So I'll just go ahead and delete this. We don't need that. So now, what is this go mode and go sum? So if you guys are familiar with, let's say JavaScript, there's something called yarn files, right? Yarn and yarn.log, or a package and package.log files. So these are basically the project's configuration kind of things. Or in Python, you can in Python we use requirements.txt. So what happens is whenever we are running a file, right? For example, here I am requiring this typesense.go. Let's say this is not here. Like currently in my file, I'm not using that, right? So if I run this command, go mode tidy, basically, if we go back and see, now there is no typesense, right? Nothing is there because in my file, I'm not using typesense. I'm only using this package, FMT, which is inbuilt into Golang. So it doesn't need this. Now, if I'm using some kind of external packages, let's say here now I'm using typesense, okay? Let me just clear this. So now here nothing is here, and now there is some kind of warning is there. So there is no required module. So what essentially what Go does is it doesn't keep all the project, like third-party package files within the project. It doesn't keep it here. It has another file within its configuration within your system. It keeps a copy of it. So whenever we push this to repositories like GitHub and GitLab, etc., it doesn't push all these typesense files because it is already there, right? It is already available on internet. So basically what it does is it just keeps a reference to it in the Go mode file. For example, if I run Go mode tidy here again, see now it is actually finding the modules, downloading it and making a copy in my system, and it is linking it. Now this errors will go. See, the errors went, and within the Go mode file, that stuff came, right? Now when I push this to GitHub, and if you guys are like if you guys are downloading the repository or forking the repository, when you run this go mode tidy, it will automatically download it into your file. It only needs to know this line in go mode. So that is what this thing is essentially is. And go sum is also something like this. Go sum is basically you don't really need to know a lot about this. So whenever you run go mode tidy, it goes and gets some hash and some versioning. That is something inbuilt. You really don't need to know about this. Most of the time, go mode is enough. This file will be automatically created if this is there. So that is it with the packages go mode and go sum. Essentially, if you guys are knowing JavaScript, this might be clear now itself. Okay, now we'll just go to our thing. Where is it? Okay. Now we'll just run this. Okay. So go mode. So it print this thing. So what is FMT? FMT is a inbuilt package which provides us with a println. What println does is it prints the given string into the standard input output. So in Hello World, when we see the Go by example, we can see other ways of doing this. Now, what Go run does is it basically this command is only used when we are developing something. So essentially, when we are going for production, we'll have a binary file which can be directly deployed, right? So to create a binary file, we just have to change the run to a build. We'll just try that also. So, see now here only three files are there, right? Go build dot. Sorry, go build dot. Essentially, it compiled it into a binary stuff. This cannot be displayed, but it can be run now in any computer. Like that computer needn't even install Go. Okay, even if your computer doesn't have a Go, you can just copy this file and just run it like this. See, it runs. So this is how. So basically, this is how we deploy stuff to production. We actually build it into to the binary, and we copy it into the server and just run it like this. This is how a Go program is run on production. So that is not needed right now. During development, we'll go with the Go run itself because that doesn't unnecessarily create a file. So that is it with like introduction. Now you are getting a hang of it, I guess. We'll go to basic stuff like values. So there are different values like integers, strings, floats, booleans, etc. Just like other languages. There's nothing very much different in Go with this. Like for example, strings can be concatenated like in other languages, just like this. There are numbers. Numbers are separated into two things like integers and floats, which is also common in other languages as well. Then booleans true and false, and boolean operators like and or not, etc. I hope this is clear. I don't want to spend a lot of time here. I'm going to the next thing. Variables. So variables, just like other languages, Go also has variables. The concept of variables. So unlike JavaScript or let's say Python, like we have to have a very clear type. Just like in the introduction where I said statically typed language. So what is statically typed? So basically, even like just during the compile time itself, Go should be able to know what kind of a variable, like what kind of value will a variable store. So why it helps is basically there won't be a lot of errors during runtime. Like in JavaScript, for example, JavaScript is an interpreted language, and what happens there is there will be a lot of issues when it goes to production. In production, when the system is running, when the system is running, only we'll get some kind of errors. So let's say like there is a if else condition, and when we are testing, we might only test the if case. The else case we might miss, and there is some kind of variable which doesn't support a push. Let's say there's a variable a which is an integer, and for some reason we try to do an array operation like a dot push or something. That will cause a runtime error in case of JavaScript. But in case of Golang, all those errors will be captured during runtime. I mean, during compile time itself, because it knows exactly what type it is, what kind of operations are possible on that. So I'm not going more deep with this. I'll just show this example. So here essentially we are just saying where a equal to initial. You guys can ask me where is this type. I'm not mentioning any kind of type here, right? So Go's compiler is much more intelligent. It can inherit its type from the value itself. So here we are directly declaring the variable, right? So it can understand that a is a string. But from this point on, a can only be assigned with with a string value only. You cannot assign an integer to a after this. So we can declare multiple variables in a single instance, but the type should be same like this. C, b comma c int equal to 1 comma 2. Even this int is not really needed. Just like this case, it could have understood it. Boolean and normal int. So here we are not assigning any value. We are just declaring it. So when we make something like this, e will have its default value. So every type in Go has a default value. In case of int, it is 0. See, when we run this, this is the output we are going to get. So in case of the int, it is 0. In case of Boolean, it is false. In case of a string, it will be an empty string. etc. Like that. Every type has its own default values. So this is how we declare a variable without actually assigning any value to it. That's it. We'll just move to constants. So what is a constant? Just like in other languages, constant is something that cannot be changed once it is actually defined. See, in this case, S is a string which contains the value constant, and this value of S, right, it will be constant for the remaining lifetime of this program. It cannot be changed. So where do we use things like this? So let's say we have some configuration variables. Let's say some database connection URL and their passwords, etc. So all those things will be constant throughout the program, right? It won't change. But for example, a pi value, if you are writing some mathematical program, the pi will be a constant, right? You can just assign it globally and use it everywhere. It won't change. So that's it with constants. So we'll just go to the next thing. So in Golang, there is only one loop construct. In other languages, there is like while loop, for loop, do while loop, etc., right? In Golang, it's straightforward, just like I said, it is simple. It only has one kind of for loop. So we'll just go with how we are using for loop here. First example is let's just like any other languages, it can be understood. I is one for I less than three. We'll just run this block of code and again unless I will become greater than three. That is what is being done here. This is just like C++, the same thing, syntax, if you guys know that. So basically, here we declared I in separate line and we are using it in for loop. Here, both are done in the same line. Basically, J is declared and used in the for loop, and also this line is also within the for loop first line itself, right? Everything is concise here. This is an infinite loop. It never, if you miss this break statement, it will never come out of this. Your machine will go into a hang, like it will hang. Okay, basically. Now, just like break, we can also use continue. So what basically continue does it? If this is hit, it won't go to this line. It will just go to the next iteration, and break just comes out of the loop. That's if you guys are doing some other language, you guys will be already familiar with break and continue. Going if there is any doubt, please ask in the QA. I think there's nothing. You guys are already familiar. Oh, there's QA there. Oh, I'm sorry. I'm sorry. I didn't see that. I'm sorry, guys. Okay. What does Go one means? Okay. So first I will answer mangrove. Okay. What does the Go 1.16 line in the Go dot? Okay. Okay. Wait a second. So here. So there are different versions for Go. Currently, in my system, 1.16 is used. So this also helps the Go compiler, like the Go runtime in your system, right? Which you install. For example, let's say you install Go 1.15. So it can understand which all library that is supported. Like let's say this Typesense, right? If they doesn't support 1.15, it can readily understand that, and it will show the error even before running that. So you don't have to worry. It will only be needed if while developing. Once you build a binary, right, it doesn't matter actually. So during production, it really doesn't matter. So when you are developing, if let's say one of your developers are using 1.16 and they are using some kind of package which is only supported in 1.16, and tomorrow when you are running, if you have 1.15, even before running, you will get the error that this particular package is not supported by your version of Go, and you'll just have to update it or maybe downgrade the package, something like that. It's just for the Go runtime to understand, Go compiler to understand what kind of version, like using which version did this application was created, like coded. I hope that is clear. Yes, yes or no? Thumbs up if yes. There's nothing. Okay, I'll just go to the next question. Is there too much learning curve? Okay, that is a very good question. Actually, there's really not much of a learning curve for Go because most of the things are just like any other language. If you're learning let's say like JavaScript or Python. It's just like that itself. However, for a front end developer, this might be a little, you know, little bit confusing because of types and stuff. Like if you're a hardcore JavaScript developer, this might be a little bit hard because I have some of my friends who are front-end developers. They are familiar with JavaScript. They are really good coders in JavaScript. But when they try to learn Golang, this type and the compiling and stuff that they didn't get along with that. But apart from that, if you're really beginner to a language, Go is really a very good start. It is fairly straightforward. Just like I said, whatever you see on screen, right? That essentially sums up everything. You really don't need to know some tricks and tips of this language because everything is straightforward. Just like the for loops and stuff which I'm saying. In other languages, there are multiple different kind of loops. Here, it is just straightforward for loop. With this, you can do everything. They are really not needed by other kind of constructors for this. So I would say there is not a very huge learning curve for Go. You can get started with this, make your APIs and stuff with this fairly easily. Uh, yeah, that's it. And even concurrency is built into Go. So if you're developing something really hardcore, even that will be easier in Go than any other language, I guess. Okay, we'll just continue. Next tag, okay, next thing we'll go with if else. There's no program which where if else is not there. There will be always some kind of condition that you will need to match. So very basic examples. Yeah, the main difference you can notice is in other language there will be a parenthesis here. So what I mean is something like this. Okay, this entire thing will be covered with this. So that is not there in Go. They have removed almost all the unnecessary things from a programming language. Uh, So this is how this is fairly straightforward, right? 7 modulus 2 equal to 0. Then print this. If this condition matches, it will go here. If otherwise, it will go here. If and else, that's it. Uh, there can be a single if statement, and then there is something like a complex if else if statement. So up to 3 or 4, you can use this kind of syntax. But apart from this, like if it is going bigger than this, if you have multiple, let's say like 10 or more conditions, then if else if is not a really good way. There's something called switch, which will come to know in the next slide. So this is basically what is if else if. So if you run this code, you will get this result. It's just if you guys just take a look at this, you can understand that there's nothing, like rocket science here. So main thing is just like I said in the initial beginning slide, there's no ternary if in Go. So ternary if is essentially this thing. Uh, I'm sorry, I'm just showing something. Okay, let's say like b equal to true. So this JavaScript. Now, if you want a equal to b question mark 1 or 2. So basically now a is 1. Why? Because here we are saying if b, then assign 1, otherwise assign 2. That's what we are saying, right? Now let's say there's something called b equal to false. Now a equal to b question mark 1 comma 2. So in this case now a is 2. So this is a very good shortcut, right? This is something front-end developers will be missing when they are coming to Golang. There's nothing like this. Everything, even for this, you will have to write at least a 4-line if-else condition like this. There's no other way. So that is what I meant by simplicity, which is a curse and a gift. It's a gift because it's easy to understand. Anyone can understand this than a question mark and a colon, right? This is understandable. But there is like the problem is you have to write 4 lines instead of 1 line. That's it. So we'll go to switch. Switch is essentially another conditional constructor. So switch is also similar to other languages, but there's the switch in Golang is much more advanced than switch in other languages, I guess. So basically here it says that we'll switch with I. So I will be validated against each of the case. So in this case, I will be validated with 1. So if I equal to 1, then this line will be printed. But in this case, we already know that I is equal to 2. Oh, before that, I think I missed something. You guys might not knowing what this syntax is. So this is a shortcut for variable declaration and like assignment. For example, you could have written it like this, where I equal to int, then I equal to 2, then fmt dot println. Okay, you could have done it like this. Where is this? Okay, so instead of this two lines, right? Now we can make it into a single line. One is this way. This will also work. Even in this case, there are a lot of things written, right? We can now remove this int. This will also work because Go's compiler is really good enough to know how this works. But this can be reduced a further step. We can even remove the where and do this. See, this is how good Golang is. Like its compiler is really advanced. It can understand a lot of, like it reduces a lot of code this way. But I know there are things like if else and stuff which we have to write with 4 lines itself. Okay, this is showing error because we are not using this thing. We'll just go with low multi. Okay, now it went. Okay, because we were not see that is how advanced Golang is. If you're not using something here and you have by mistakenly imported it here, even that will be shown as an error. So that is really good. Other languages like JavaScript and stuff, it doesn't really show that, and we really miss to remove some libraries which we are not using anymore, and it will take up space in the final build. So essentially, Golang is really advanced. It can understand even that. So that's it. We'll just go with the next thing. Before that, let me see if there's any questions. Okay, nothing is there. Okay. We'll go continue with switch. I'm not taking a lot of time. Okay. So in this case 2 will be executed because I is equal to 2. And once a case is executed, it doesn't go and check the other case. Unlike in some other programming languages, even in a switch case, right? If we don't use a break, so usually there will be a break after this, just like in for loop. If there's not a break, the switch statement will go to the next case also in other languages. But in Go, it is like if one case is executed, it won't go and check the other case. It will just exit from here. We'll just take another example. So in this case, time.now. So time is an inbuilt package which give us a lot of functions with which we can manipulate and use time. So in this case, time.now.weekday is being checked. So see, this is a very good thing about Golang. We can actually combine multiple cases. Let's say we want to run some kind of function if it is Saturday and Sunday. So if it is Saturday or, I mean, not and, it is Saturday or Sunday. So essentially, if the weekday is Saturday or even if it is Sunday, we want to run the same line, right? Look how easy it is. Like in other language, this will be another case, but doing the same function. That will be redundant, right? So this is a very good thing about Go. And finally, there's a default case. What default case is? If it doesn't match any case, it will go to the default case. So in case of this example, every other day is a weekday. That is why the default case is here. So that is clear, I guess. Now, in this case, okay, there is something even more advanced in Golang, which I haven't seen or maybe I haven't used in any other language. You can actually go and check for conditions. Just like in if, you can just straight see, there's nothing to compare here. In this case, we are comparing time.now.weekday. In this case, we are comparing I, right? So in this switch statement, see, there is even nothing to compare also. They are directly going with this. So if the hour is less than 12, this will be printed. Otherwise, it will go to default case. I hope this syntax is clear. This is something which no other language is providing, I guess. Right? Okay. Mm, okay. So that is like basics of switch statement and all. We'll just go to the next thing. This is not needed right now. You guys can go and check this website out for more complex thing. I think time is good. I will go to arrays. So arrays is basically a numbered sequence of elements of a specific length. Within the memory, it will be in sequence. So this is how we create an array uh, variable A, and this is how we array of integer. So this is an array of integer. Even arrays has types in Golang. So every array will contain only one of the type. If an array is integer, it can only contain integer types like that. If it is a string, it can only contain string type. So this is how array is declared normally. So that it can also we can assign values like this. So 4 will be the index, just like that. So in this case, we are declaring and putting values directly. This is the syntax for putting values directly as well. Then what else is here? Variable to, okay. So this is a multi-dimensional array. Okay, so these are like basic array things itself. If there is any doubt, please ask me, because I'm not going to go deep into this. These are all basic programming things itself. There's nothing new here. For loop and stuff. Okay. So what are slices? Now, slices are actually the more important thing in Golang. Slices are essentially the normal arrays in other languages. So slices are used, like are built using an array. This will be a very confusing part here. So basically, just keep this in mind. You guys are never going to use arrays in your program. So wherever you might need to use arrays, you will be using slices. Okay. So what are slices? Slices are much more advanced arrays in Golang only. So in Golang, arrays are very basic things. Every array is basically a fixed thing. We cannot change its size. We cannot decrease it, like increase its size. Let's say you define an array with 5 length, you cannot increase it. Okay, and array is not a pointer, unlike other programming languages. So all those things are solved by using slices. Slices are essentially arrays itself. So slices can be increased, like its length can be increased or decreased. It can be appended, like new items can be added, even if it is more than its current length. It can be basically copied to other slice. So basically, slices are like pointer in like, just like in other languages. So slices are arrays in other languages. That's how I keep this thing in mind. So essentially, you are going to use only slices everywhere. So the this is how you build a empty slice. So make is something new we are reaching now. So make is something inbuilt to create default things. What this makes is an empty slice, and if you print this, we are going to get this result. There's nothing inside the slice file like that. Now we can assign values into these three values: s of 0, s of 1, and s of 2. Now if you go with s of 4, s of 3, it will give an error because there is nothing, right? Now you can ask me a question. Then, like I said, that we can increase space. So to increase space, we will have to use the inbuilt function append. Now, if we use append, it will automatically increase the size, add d also, and give the result back. We'll have to reassign it to s again. So this is how append, and copy is also there, which is not there for an array. And any array can be easily made into a slice basically. If you basically if you use an array and append it, it will be automatically converted into a slice, because inside a slice it is already built using an array itself. I think this is getting a little bit confusing here. If you guys play around with this, you will understand this easily rather than me saying this. I'll go to the next thing, right? Uh, oh, Akshay CJ done this, I guess. Okay. Uh, I think that is answered. Cool. Akshay CJ, was that answered? Okay, I'll just go with the next thing. We'll come back. I'm just skipping slices for now because it is a very huge topic. There is a very good blog post for this. I'll just see the link. Okay, so I'll just put it here. Okay. Next thing is maps. So map is an associative data type. So it is basically like a what do you say? So a dict in Python or a JSON object in JavaScript kind of thing. That is what essentially a map is. So in Golang, again, just like slice, we can use the make inbuilt function to create an empty map. So here, even for map, we will have to define the key and the value type. Here, the key type is string and the value type is int. So essentially, so map is m, right? M of k1 equal to 7 means within the map, the key named k1 will be containing the value 7. That is what this means. So when you print this line, we can see it here. See? V1, so V1 is M of K1. So V1 is M of K1 means it is 7. We can also get the length. I forgot to say this. Length is also available for arrays and slices as well. So length of this map is 2 because we have only 2 keys and 2 values assigned to them respectively. We can delete a key directly because even if you set this key, right, even if you set M of K2, for example, for its 0 value, it will still be there. The length will be 2. So if you actually want to delete it, we'll have to use this key. So after this, the length will be 1, like that. And this is a very good syntax which is useful if you want to get the values, right? You can use the syntax to assign values to, let's say here it is A and B. Just go to the code. Okay, let's say hmm, let's say I'll just copy this. Okay, so in this case it was A comma B. So now K2 will be assigned to A. We'll just say A comma B here. So this is PRS. So see here. Okay, sorry, it will be the index. I'm sorry. M of K1 will be A and B. The second value will be okay. So this thing, this part I will explain when using a for loop. That uh, we will go to a next section for range. So in range, this will be more clear. The syntax will be more clear there. But this is not used anyway. Wait a second. I'll just go to range here. So range is something like which is really useful. We can use a range to iterate over a array, slice, or map. And in map specifically, the syntax. This is where I was going to go. Okay. So here you can see that we want to iterate through this entire map, and we can use this syntax here. So this range will do the iteration part, and during each iteration from the map, it will get two values, right? The key and the value. So this is how we get key and the value. Now, if you want to only iterate through the key, you can just do like this. This will also work. So this will essentially iterate through the key only. It doesn't take the value part of it. So this is what I was going to do. That syntax is clear, right? Okay. Uh, Next is functions. I think this is taking a little bit of time. Functions are like essentially every programming language need a function. So this is how we declare and define a function here. So basically we need a keyword func, F-U-N-C, the function name, and the parameters that we want to pass when we are using it. This is the return type. So essentially in Go, we can have multiple values being returned from the same function. This we'll get to know in the next slide. So here, this is a very straightforward function. If you use this function with a and b, it will return a plus b. Now this is just same thing, straightforward thing, right? Okay, so the difference is if all the variables are same or of the same type, then we can use this syntax. Only use the other syntax if multiple types are there. Now, okay, this is the output which we get. So plus one comma two, that is one plus three. A plus b, one plus three, one plus two, that is three. One plus two plus three, again a plus b plus c, you get six. So we'll go to the multiple return values part. So here we can see that there is a, like, the parameters are empty, but the return types are two, right? So we can basically return any number of values from the same function, which is also a very good thing. But keep this in mind. Don't make this a very huge number. Okay. Essentially, what we do in Zoko is we basically keep this number to two or three, maximum up to four. At worst situation, we return four values. That is the maximum. Go doesn't have any limitations. We can, return maybe, I guess, 10 or 15 items in a single go, but that is not advised. It won't be readable later. So that is a thing with function, and there's something a little more complex, that is variatic function. So what variatic function is, basically, you don't know exactly how much numbers will be passed. For example, in case of the sum function, I mean, the plus function which we saw in the previous slide, there was one function with two variables which accepts two variables, and one other function which accepts three variables, right? But let's say you need a function which accepts a lot of variables. For example, the sum. Into sum, you can pass any number of variables, right? But there is only one catch, that is the type should be same for all the variables. So here, it will accept any number of integers to this. And using the range and for which we learned in the previous slide, we can iterate through them and calculate the sum. Now you guys can ask me what this is. So this is basically when a variable is not needed, we can basically use it. For example, in the previous example, right, I showed you how to use a key alone, right? But you can ask me how to use a value alone. So that is not possible. If a function is returning multiple values, you can only omit the the leading, I mean, not leading, the trailing variables can be avoided. So in this case, it will give only k, but you cannot avoid the leading. So basically, if you remove the k also, this is still the first variable, right? So in that case, if you are not using k, you can just go with underscore and not use it. Okay. So now you can ask me why can't we use k itself? But if you use k, the compiler will show an error that the variable is not used. So if you want to remove this kind of error, that is, you are in a situation where you need the second returned value from a function, and but you don't want the first value. In that case, or first or second, if let's say if there is three return things, you can use something like this also. But in this case, the range is returning only two values. So this should work. With that in mind, this is basically, in this case, range will give the index of this nums. So for each iteration, this value will go from 0 to the length, not like length minus 1. So now we are calculating the total and we'll just print it. So this is also straightforward thing. Okay, there's no questions. Okay. Closures, this is a kind of complex thing. You guys should read about this, I guess. Recursion is also, I'm not going through this right now. Now, pointers. So pointers, I'll just go through them really fast. So essentially what pointers is, okay, when you define normal variable, right? Let's say a equal to 1, fmt.println should give a, let's see what will be printed. Okay, you get the value of 1. Okay, now let's say, I'm just changing this to string and wait a second. So variable is string, variable b pointer string. So basically, this star means it is a pointer. I'll just get to that 1 second. A equal to, let's say, string, b equal to string. Now both are okay. Now here we are getting an error because we cannot assign a value to a pointer. pointer is basically something that keeps hold of a address of a value. So let's say a variable, right? We are assigning a value string to a, but a actually has an address of itself. Now that address we can basically store it into b. Let's say I'll just wait a second. Okay, fmt.println a will give you string. So this basically this thing. Okay, and just to avoid confusion, I'm just changing it to Rabi. So that it's not the type; it's actually the value. Okay. Now if I put an ampersand here, okay, I'll just explain that one sec. Now see, we are getting some kind of weird thing, right? This is basically the memory address during the runtime where this value was stored. Where this actual value Rabi was stored in this memory address. Now there is a way to store this value directly into a variable. That is what B is. So basically, if I uncomment this, now I can store the address of A to B. So basically this. Now I'm storing address of A to B. Now let's see what will happen if we print B. B should essentially print the address of A. Okay. See, it is again printing the address of A itself, right? See. Now let's say now I want to print the value ready, but not using A, but using B. In that case, we'll use this syntax. Same like this. If you give a star, it means that it is pointing to the value at this address. Address is B. Pointer is pointing to this address. So what is the pointer addressing to this address? So the value will be Rabi itself. Let's just run that. So this is basically what pointer is, and this is something you will be familiar if you were using C or C++. So we'll just go with that. So there are a lot of use cases of pointers, and we will use it in a lot of places in both. Essentially, basic thing is it doesn't duplicate the memory location. Let's say like if we are storing the same value in multiple places, right? Usually a copy of that value will be used. So memory will be utilized more than required, right? If you're using pointers, the same memory is used, right? We are just inferring, like we are just pointing it to the same location. So that is something which was needed in older programming languages when we were really old, when there was no that much memory in our systems. But now that is really not a very huge use case for pointers. There are other use cases as well, which you'll get along when you're coding with Go, I guess. Next thing is strings and tunes, which we are not doing now. We'll just go to uh, so Go routines and channels are the main thing of Golang, which allows it to do. Uh, I'm, I'm sorry. The Go routines are something which allows Go to do multi-thread, like concurrent things at the same time, which we talked initially. I'll just go through this quickly. I think is it time? Okay, yes. Okay. We'll go quickly through Go routine. So essentially, syntax wise, it is really straightforward. Any function can be a Go routine. So let's say I'm just making this into a function. Okay, func print a. Okay, so this function just prints a. This function just prints b. Okay, now let's say I'm calling print a and print b. Okay, now the result is like you guys have already guessed it. That is basically a and b. Okay. Now let's say I'm just putting go here and go here. Now can you guys take a guess? Wait a second. I'm sorry. Okay. We'll just wait for 5 seconds. So what happened is even before this functions got executed, right? The main function went. So when you put a go before a function, basically it doesn't wait for this to finish. So basically, in the first case, right, the print B statement is only called after print A. But when you put a go here, it just it just starts running this, but at the same time it will go to the next line. So what happened is when I put to go here, it basically went and exited. So let's just put a sleep here so that we can wait for some time for these two functions to be executed. It's not executing. Wait a sec. Wait. See, okay, now this is enough. We'll just go with this. Yeah. Okay. So now B is executing first, then even though this was run first, let's say there's something else. Let's say there's print C. That is clear. So time dot sleep did play something with them. Okay, now what happened is basically this function started in a separate thread. This function started in a separate thread. This got executed, and we were waiting for 10 seconds. And within that 10 seconds, this too got executed in some random order. It won't always be like C will always be first, but A and B need not be at the same time, right? Just see one more time. Last go, sorry. So now it all printed in sequentially. So I guess that is clear. Maybe you just execute this and see as well. So, okay, I'll just explain this. So there is a function which basically prints number 1, 0, 1, 2, 3. So first line is straightforward. It doesn't have any go keyword. So this will be executed directly, right? Then it goes to a go routine. So this thing is executed somewhere here, right? Go routine and see direct was called 0, 1, 2 directly. After this thing started, and only then it went like this will be executed in random orders because this both these functions will be called at the same time, running in the background at the same time. This is what I meant by concurrency. I think I made this a little bit more confusing than it is supposed to be. Sorry, is there any question? Okay, cool. Sorry. Okay, there's something called channels also. Even this, I cannot explain it that fast. So channels is something like a sync await kind of thing. So basically, what channels does is, let's say this program is being executed. This will be executed. A message with a channel will be made. Now this is a Go func, right? This will be executed somewhere in the background. So now whenever this gets executed, this line will be waiting. So it will wait until this thing is gone. So when this syntax is basically we are putting something into the channel. So when we are putting something into the channel, it can be accepted using this syntax. So when you put ping here, it will be going through message. So it will wait here basically. Okay, until the channel receives something. If we are using this syntax, it will wait until some other piece of code is calling this syntax. Okay, so this is what channels is. So using channels and Go functions, we can do a lot of things. Essentially, why channels is used is when we are executing Go functions, right? We have no control over it because it is running somewhere in the background. So if we want our main function to interact with Go, with a Go function, or let's say there are two Go functions A and B, if we want those two Go functions to interact with each other, in that case, a channel comes in handy. So a channel is something like a pipe if you put something at one end, it will be received at the other end. That is essentially what channel is. I think we'll stop with Golang basic and we'll head over to Typesense. So before that, if there is any question, like I'm sure there are a lot of questions in Golang, but there is really no time for that. We'll go to the next part, right? Anyway, post your questions here. If I can answer it, I will answer it right now. Okay, so we'll go with basics of Typesense. Using Golang, basically, I have given a brief introduction to Typesense. So it is basically a server, a database which contains some data which is searchable. So all the searching, heavy lifting is done by the Typesense database and servers themselves. So we are going to make use of Go client. So you can see the Go client here. Typesense Golang. If you search for this, you can get the GitHub link, which has a documentation, or you can directly go to the package.dev. Oh, I'm sorry, I forgot to mention this. So package.go.dev, this is basically where you can search for Go packages, third-party or community Go packages here. This is essentially the NPM. This is just like NPM for JavaScript. Package.go.dev is for Golang. So here you can see the README, how to install it, etc. Of anything you want, you can just search it here and you can find it. So we'll go through Typesense for Golang. So before using Typesense client in Golang, we'll actually have to have a Typesense database server, right? So there are multiple ways of setting it up. I have went to Typesense website, the cloud, and I have set a cloud server for myself. All these things are straightforward. You just need to go to Typesense website. It's just log in and you can see all these things. I'm not doing that part here. Go here and use this deploy on Typesense cloud. So this is a free trial kind of thing. So even if that is finished, you can actually like run a server on your system itself using Docker and stuff. So that part, I'm not going through this. There are several options here. You can go to this website. Okay. Okay. So I'm not actually going through how to install Typesense in your local machine. Instead, I'm going with the cloud version, which has some trial period. So I have actually created a server here, and I have generated the API keys. So why API keys? We required some kind of authentication, right? When we are connecting from some external clients, like our Golang program. So now there are no collections and documents, etc. So briefly, I will say what is a document and what is a collection. So basically, what is a collection? If you're familiar with normal databases like Postgres or MySQL, collection is basically the database part of that, right? Where we have a lot of tables and stuff. So collection is the database itself, and collection is a sorry. I'm sorry. Collection is a table. It's equal to the table in MySQL or Postgres SQL. Collection is same thing in MongoDB. So if you guys are familiar with MongoDB, then collection is straightforward, and document is also straightforward. So documents are like a row in a table. In Postgres or MySQL, a row in a table is document, and the table itself is a collection. So in case of Typesense, so Typesense basically is more similar to MongoDB, NoSQL databases, which so basically collection will be having a lot of documents within them. So we can only search within a collection uh, in Typesense. So similar kind of documents will be stored in a same collection. That is how usually we do things. So in Golang, first we will have to before creating a collection, adding a document, so and searching a collection, etc. We'll have to connect the client to our server, right? Just doing that. Sorry. I should have used some other file for this. Sorry. Okay. Okay. So basically, I have done some things here. I will explain it. So before that, we will do our favorite go note tidy. Okay, cool. Okay. So just like we said, we have a package main here. And we have a main function here. Now everything is commented out. So first, we'll have to create a Typesense client. So we'll go to that. Now this red line is because we have declared it but not used. So essentially what Go is saying that remove that line because you're not using it. We are not going to mind it because we are actually going to use it, right? I'll just uncomment this line also so that that error is not there. So now we'll go through each function. Now create client. So create client is a function that I wrote within which we are using functions from Typesense. So how to create a client? So in Typesense, right? This library. So this is imported from this import this package. So Typesense has a function called new client. So within new client, we will have to pass the server address and the server API key. So from where did I get this? So I got that from the API keys. When I created this API key, they actually gave me that key to copy. So this is where I got the address. https://typesense.net on port 443. So that is what I have done here. This is the address and this is the API key. Now, there are once the client is created, see the client is created here. So during the client creation, right, this is a function which returns two things. So in Golang, if you're using VS Code, you can actually hover on the function and you can actually read the basically the documentation from here. You don't need to go to Google and search for the documentation. You can actually go and read it here itself, or even better, you can command click in Mac or in Windows, I guess it is control click. You can actually go to the function and actually read it if you want. So that is also possible. That is actually not needed. So if you hover here, you can actually see the documentation, right? They haven't given a documentation here, but let's say, for example, this is the documentation for this function. So if I'm here, if I'm hovering, I can actually see it here, right? Create Typesense client. For some reason, they haven't actually given a documentation here. That's why nothing is coming. But at least we can see what kind of return types are there. So they are returning Typesense client kind of. This is a type of struct they are returning. So that is a type of client here. Now within this, if if even if you don't know what kind of functions are there, we can just type. See, it is already filling us with things, right? A lot of things like this. If they have written comments, even that would be here, like documentation, just like how we saw in this case. So I think it is not here for now. So this health functions will check the health for 10 seconds and it returns either an error or if it's healthy, it will return a true. So after this function, what I am actually doing is if there is an error, I'm just going to exit. So what is fatal F? Fatal F is basically printf followed by os.exit. So what it does is it will print this to the standard output and will exit the program. So this usually in Go program you won't directly write this. This is just an example. That's why I'm going with this. So if in any case there is an error, you just exit the program, printing this thing. So now the next thing is if there is no error, but for some due to some reason if it is unhealthy, like if this is false, even in that case I'm doing the same thing. Typesense client is created but not healthy. So if everything goes well, we'll just print Typesense client is created and we'll just return the client from this function. So basically we got the client here. Now the next step is to create a sample collection, right? We'll just go. So before creating the sample collection, we'll just run this code and see. Okay. Okay. So creating and Typesense client is created. So that part is working. Now client is created means it was successful connecting to our server. Now, after connecting, we will need to create a sample collection, right? So we'll go to this function. What does this function do? So in this function, basically, every collection will have a schema. Okay, what is a schema? A schema is like a configuration for that collection. It's just like in Postgres or MySQL, we'll have a structure for the data, I mean, for the table, right? We will already define what kind of columns it will have and the properties of column, whether it is null, whether it should be primary, etc., etc. So it is something similar. And usually, when you write a actual program, this won't be within a function like this. This will be in a separate file. But now we are just going through a sample. That's why it is within the function. So there are different fields like this collection will have a field with name. So every document in this collection will have a name. I mean, sorry, I'm just sorry. This is the name of the collection itself, companies. Fields are where we will define individual fields. So every document which we are going to put into this database will have a name, field called company name, which will be having a type string, another field called number of employees, which will be integer. Another called country, which will be again a string. Then a facet, whether it is a facet or not, that's what we are giving here. Then default sorting field. So default sorting field is again set to number of employees here. So in this collection, within this collection, every documents will have these fields, and every field will have its own individual properties. There are like a couple of other properties as well, which even I'm not familiar with. You can go through Typesense documentation to get more info on those things. So now we are going to create this collection using this schema. So how we are creating that? So essentially, we are getting the client, right? We are passing the client from here. We created a client and we are passing the client to this function. So we are accepting it as a TS client. The variable name is TS client. Using this client, there is an inbuilt function called collections, which will return a list of functions which has a inbuilt function called create. So this is how we create a collection using the Typesense client. So using the schema, we created a client. Now, during creation, there can be some kind of error or some, if nothing is there, there will be a response. So why did I put this like this? Because I'm not using that response in any way. That's why I put it like this. So if there is any need, we can actually utilize that as well. So what does the return type look like? Looks like a collection response. I think we don't need to know it right now. So if there is an error, so what is error? Not equal to nil. Nil is the default for an error. So if it is not equal to nil, that means there is some kind of error, right? If it is not nil, means there is some kind of error. Before that, what is nil? I am again sorry, I didn't say this. Nil is basically null, null, null in JavaScript and other languages. That is basically nil here. So just like for an integer, the default value is 0. For an error, the nil value is nil itself. So if there is an error, we'll just exit out of the program for now. So this is how a collection is created in Typesense. Just run it. So create a collection. So before running, I'll just go to Typesense. So here we can see everything is zoomed out because there is no collection, right? New collection button is there. So everything can also be done using this UI. But for now, we'll run this function to create a collection. So a Typesense client is created first using this. Then after that, we are creating a new sample collection. A sample collection is created without any errors. Now, if we refresh here, let's see. Okay. So see, now actually we got a list of, there's only one collection here. We can actually see the schema. So this is the schema that we use to create this collection. We can add documents from here, delete the collection itself, etc., etc. So next thing is basically that we can actually drop the collection completely. All the documents, everything will be gone. So the syntax for that is also fairly straightforward. It's basically instead of create, we'll just give delete. So we'll have to give the collection's name like this. If there is no error, we'll successfully delete it. So I'll just run it and I'll show you an error case also. So in this case, we actually got an error. Why did we get an error? Because we run this create sample collection again, and there exists a collection named companies already. So you can go and see the error here. See, failed to create sample collection. 409 response. What is the message? A collection with same name already exists. That is why we couldn't execute beyond this because we are already exiting the program here. So if there is an error, we are exiting it. So there is no use of that. So we'll just comment this line and run it again so that we can delete the collection. Okay, sorry, go run. Okay. See, now we have deleted the collection. We'll go and see here. Okay, see the collection is gone. Okay. Now we'll again create a collection and go to the next part. So after creating a collection, what is the next part? We actually need to index a document. So what does index a document mean? So indexing is nothing but a fancy way of saying creating or inserting a document into a collection. Okay. So that is what we are going to learn next. So there's a document one. So document, what is a document one? Document one is basically these data. So every document will have an ID and its corresponding fields as defined in the schema. So in schema, we already defined a company name, number of employees, and country. So this is how we define, like insert a document here. So ps.collection.companies.document.create a document. Even in this case, error or a response will be there. If there is no error, a sample document will be created. Okay. Before moving along, is there any doubt right now? I'm seeing that there. Okay, actually. Okay, cool. Next, so we'll just run this code and see if a document is added. See, a sample document is created with ID 123. You can go and see it here. So we'll go and search for that. Okay. See, we can see the document here. Staff industries, number of employees, USA, etc. So basically, if you search, this is what we are going to do. Okay, searching is working. Result for Ruby, no results. Now we can add other documents as well. So before adding a document, we'll just delete the collection once again because or maybe we'll just comment this out, right? Comment this out and we'll just add two more documents. Now document 2 and 3 is created. Now there's a different in creation here. So in first case, we are using a create keyword here. So create is basically create a very new document. So if we create this document again, right? Let's say I try to execute this code again. Let's say document one, okay, with the same ID. If I'm trying to create it again, we'll actually get an error. See, a document with that ID already exists. So that is what create does. But in case of document two, not document two, document three. Okay. In case of document three, I used an upsert. So what an upsert is basically, instead of if the document already exists, then it will just update it. So if in case I just change this to USA, it just changes that and update the document. That's the only difference there. Okay. I hope that is clear. So let's just see. So what happens if I run it here? It shouldn't give an error. See, it didn't give an error. It just upserted it. Okay. Now there's just like deleting a collection, we can delete the documents as well. Oh, I'm sorry. So we just go with 789. So 789. Okay. This should be a string. Okay. So the document is deleted. Now we'll just go through the deletion code. Even that is straightforward collection or document or delete. So all the heavy lifting is already done within the Typesense client itself. We just need to call it. So from companies, the doc ID which we pass through the function is called here, deleted. If there is no error, we'll just print the document is deleted. We'll add that again for our searching. Where is that? Document 3 was deleted, right? Okay. Now, sorry. Okay. It is also added. Now we'll go to the main thing, that is searching a collection. So here in search collection function, we are accepting the client and a query, and we are actually using ts.collection.documents.search. So what does search take as an input? It takes a search parameter object. So what is a search parameter object? So it is basically this struct. This is kind of a, so I am wrong by calling it as an object. I think we didn't go through struct, right? I think I missed to explain that. I'll just give a very brief introduction to what a struct is. A struct is basically okay, it can be uh, combined with object and like class and object in object-oriented language. However, it is not same. Struct is something like a class itself. Similar, it contains similar kind of data. Like for example, let's say there is a struct called user somewhere. I'll just give a very, I missed it. I'm sorry. Type struct, type user struct. So struct, we can give a name. Every user should have a name. Okay. Every user will have an age. So something like this. And we can actually go and create a variable of that. A equal to user, basically. Okay. Name, Rabi, age, 25, stuff like this. And we can use a dot age or a dot name. It's almost similar to object and classes if you are familiar with object-oriented languages, but it's not same. And every struct can have its own functions, which are called methods. But that is a little bit deep for now. You really don't need to know right now. So essentially, this client and all, even this is a struct basically. So we'll just go to see Typesense. Where is it? Typesense of client. See, client is a struct. Every client will have a API config, API client, collections, aliases, stuff like that. I'll just go with what we were doing. So we're talking about searching. So when searching a collection, we'll have to pass a variable with all this search parameter struct. So within the struct, we can define a lot of parameters are there. We will just go by the basic thing. Essentially, Q is the basic query, the text which we passed from here. That is Q. Then we can query by what? Like where should we search with this? We can search for company name, right? Within that field, we are going to search. We can filter by a particular value. Now here, all the number of employees greater than 0 will be filtered. So if I put here 5,000, this search will only search for that company name, only those companies which have more than 5,000 employees. That is what basically filter by is for. So let's keep it 0 for now. And the results can be sorted by a sort by string. So in this case, I'm sorting by number of employees descending. This is the syntax. All these things you can check in Typesense documentation for this syntax, like number of employees colon the ESE. This has nothing to do with Golang. So that is how we define a search parameter. And each time when a user actually searches, we actually create this configuration and pass it to the search function. So if there is no error, then we'll reach here and the response. So see, in every other case, I have been using this thing because we were not using the response. But in this case, we are actually going to use the response. So with the response, I'm just printing out what did we found and the data also. Okay, we'll just there can be multiple hits, right? For example, let's say there is someone called let's say there are two companies called Zoko and Zoho, and for some like when you search for Zdo, both the results should come, right, like that. So multiple results can come for the same search. So it will be an array, and we can for loop through it and print the array as well. We'll just run this. To run dot. So basically, we searched for Aviyel and we found 0. So did we actually add it there? Let me see. I'll just refresh. Okay, Aviyel is there. Number of employees greater than 50. Okay, it is actually there. Why didn't we get that? The spelling is correct, right? Let's see it start. Okay, staff is coming. So basically, we found one document matched. Staff is coming. I don't know why Aviyel didn't come. Maybe why. We'll just try it one more time. Oh, okay. Okay, now it worked. So basically, we found one hit. We got Aviyel here. Let's add one more document so that we get at least 2 hits. Let's say document 3 can be changed. Let's say Zoko game. Okay. We'll search for Zoko, and this time we'll have to get 2 hits at least. So we actually got 2 hits, and the for loop went through both of them, index 0 and index 1. Both the time, the company name is Zoko, the ID is different. And see, in this case, number of employees is 20. Here it is 50, right? We'll also see that. Let's say in search collection, there is a filter. We'll just keep it as more than 30. So this time when we search, we'll have to hit only 1. See? So this is basically the basics of Typesense using Golang. I hope it is clear. Is there any questions?
Hey, thank you so much for that session. That was really insightful. And thank you to the audience for staying in for such a long time. Really appreciate that. I'll see you in the next session. Thank you so much for tuning in.